Astronomers have just discovered a star moving at about 25,000 kilometers per second around the black hole at the center of our galaxy, and its orbit could let us measure the black hole's spin. That's more than 8% of the speed of light. The star is called S301, and it's doing something we have never seen a star do this closely to Sagittarius A star, the supermassive black hole at the center of the Milky Way. Sagittarius A star has a mass of about 4 million suns, and S301 is orbiting it on an incredibly stretched out path. At its closest point, the star comes to within roughly 12 times the distance between Earth and the Sun. That's about the same scale as the distance between the Sun and Saturn, and despite getting that close to a 4 million solar mass black hole, S301 doesn't fall in. It's moving fast enough to remain in orbit, sweeping around Sagittarius A star before heading back out again. The really crazy part is how quickly it completes that journey. S301 takes only about 8.7 years to complete one orbit. Our Sun takes the solar system around the center of the Milky Way in roughly 230 million years, but S301 can make an entire trip around our galaxy's central black hole in less than a decade. Its orbit is also extremely eccentric, meaning most of the time it's much farther away before diving back toward Sagittarius A star and accelerating to its maximum speed. And this is where the discovery becomes much more interesting than a simple speed record. When S301 swings past the black hole, its orbit is being affected by the extreme curvature of spacetime around Sagittarius A star. Einstein's general relativity predicts that the orbit should slowly rotate rather than tracing exactly the same path every time. For S301, that relativistic shift is about 2 degrees per orbit, which astronomers can actually look for in their measurements. But there's another effect they're really interested in. Sagittarius A star is expected to be spinning. And according to Einstein's theory, a spinning black hole doesn't just curve space-time around it. Its rotation can actually drag nearby space-time along with it. This is called frame dragging, or the lens-Thirring effect. Usually, that effect would be incredibly difficult to detect around a black hole as far away as Sagittarius A star, but S301 gets so close that its orbit could carry a measurable signature of that rotation. By tracking the star very precisely over the coming years, astronomers may be able to see tiny changes in its orbit caused by the black hole's spin. And that's why S301 could become far more important than simply being the fastest known star in the Milky Way. If astronomers can measure those tiny orbital changes, they could potentially determine how fast Sagittarius A star is spinning and which direction that spin is pointing. In other words, we're using a star as a natural probe of a black hole that we can't see directly. There's also something fascinating about S301's history. The researchers say its extreme orbit may have resulted from a dramatic encounter with Sagittarius A star. One possibility is that S301 was once part of a binary star system that got disrupted by the black hole, leaving one star in this remarkably tight orbit. That's still a hypothesis, though, so we shouldn't present it as a confirmed origin. And we're not finished watching it. Astronomers will continue tracking S301, including with the gravity instrument on the Very Large Telescope Interferometer, in future observations with the Extremely Large Telescope. Its next close passage will be especially important because every new measurement gives scientists another chance to see whether the black hole's rotation is subtly changing the star's path. So somewhere near the center of the Milky Way, a star is racing around a supermassive black hole at more than 8% of the speed of light. And every time it makes that extreme journey, its orbit gives us another opportunity to learn something about the invisible object controlling it. S301 isn't just the fastest star we've found. It could become our best natural way of finding out how the black hole at the center of our galaxy actually spins. If you want to see what astronomers discover next, subscribe to Cosmic Pulse.